Quick update on the family. They're the most important. We had our oldest daughter get married, so our family's growing and changing. Our team continues to grow. We keep adding people and places and some new faces. Most everybody's still here that's been with us, so glad for that. And we continue to serve more geography. So this year, kind of new for us, is pushing down into Texas a little bit, there in the Panhandle, and out into Ohio a little bit more. So the geography of where we're covering is getting larger. We've talked a lot about water quality today, and I think that's something that is super important for all of us to consider as I look around the room and those that are online. Water quality, it's been said already, but it is your #1 fertilizer input. And we need to account for what is in that water and how it's impacting the balance of what's happening in the soil. This was a picture, you've probably seen this if you've heard me talk before, but this is just north of here, 3 miles. In 2020, we had ideal rainfall, and underneath the pivot was worse than in the corner. And so we went in, did some soil sampling, we figured out that we were tying up calcium with our water, and the water was making the calcium that we thought was high enough, it was making it unavailable to the plant. So just understanding that water can be a negative. There's things in that water that are making this whole balance get out of whack. Another picture from one of our growers in Nebraska. Again, what was underneath the pivot burned up. It was a high sodium situation. These things can be treated. One of the reasons that this is becoming an increasing problem, this is the pH of rainfall. So if you look at this red line here, if you go back to 2000, the pH of rainfall was just under 4. So every time it rained, it was giving us free acid fertilizer, right? It was hitting the reset button. This chart goes to 2020, we were up to about 5.8. I checked some rainfall last fall, and the pH here was about 6.3. So this chart has continued, this number, if it was to continue, would be clear up here now. So as they clean the air up, the water that comes from the sky is no longer treating the irrigation water effect that we used to get. And so I think this is one of the reasons that these problems are compounding and getting worse with time. I just want to reiterate on some things that have already been said and kind of say it again in a little different way. If we think about what that plant experiences, it goes out into the soil, it puts its root hairs out, and it extracts the nutrients through the water, right? It brings that water in. And so the only nutrients that are truly available to the plant are what's in that soil water. So again, that's what a rapid soil test is. It's testing that water that's basically what they do is they mix your irrigation water or the deionized water with the soil, they put it in a vacuum, and they suck the water out of the soil. And so that's simulating this effect that plant has when it's growing. Clint already touched on this, but this quote here, it says, "The soil is the worst place to store nutrients, especially P and K. Phosphorus and potassium get tied up on that soil colloid, and they become unavailable to the plant. They don't move back into that solution easily. And so we've got to think about when we apply those nutrients, what's actually going to be available to the plant. One of the books I read this a year ago, it basically said that phosphorus, we're about 10% efficient with phosphorus. So we put $1 of phosphorus fertilizer out via 1152O, you're only getting 10 cents of that back. I think we can do a lot better than that if we put it in through the irrigation. Where you have a drip system, it makes way more sense to put it out there in small amounts, get it in that soil water solution as the plant needs it. So replace soil applied fertilizer applications with ppm applications in the fertilizer water. That's the direction we're moving. One of the questions that we'll have to answer is how much of your fertilizer budget should be moved into the fertilizer water. And I think it's going to vary based on nutrient, but it's probably going to be somewhere between 50 and 80% of your nutrients should be going in through the water. On phosphorus and potassium, it's probably going to be up on that 80% range. On the nitrogen, it may be down in the 50 to 60% range, but that's something we'll be working through as we get more of these results back in. So a couple key takeaways, just to reiterate this. Why have we gotten mixed results to different fertilizer applications? I think all of us have applied things and we didn't see a response. Now that we look at these new testing methods and we think about those interactions and we think about the rank of different nutrients, now it makes sense. We didn't understand what the rank of those nutrients was. This third point, I want to hit on this. The plant cannot select between different anions and cations. Clint said this earlier, but just to reiterate what that means. If you take all of your cations, so the cations are calcium, magnesium, potassium, and sodium, and ammonia, and the plant needs a cation, it can't choose, it has no mechanism to choose potassium. It doesn't have a mechanism to choose ammonia. It brings them in by mass flow. And so if we have one that's way out of whack, and it's, let's say sodium is overriding potassium, the plant gets sodium instead of potassium, and it can't do its processes that it needs to. So that's true with both anions and cations. I always had the understanding that the plant, when it needed nitrate, it got nitrate out of the soil. It's not how it works. It brings in cations and anions. And when they get out of whack, our job is to balance that. So I just learned that last week, and it's just made me think about things differently, that plant can't choose what it's getting out of the soil. Think of your deionized water. So going back to the rapid soil test, deionized water that's what the plant experiences when it rains. Okay? Rainwater is essentially deionized. There's a few ions in it, maybe 25 ppm, but it's essentially deionized water. So if you're thinking about, okay, what happens when I get a year with plenty of rain and I'm not irrigating much, look at your deionized number. But then as soon as you flip the switch and you turn the irrigation on, now you've got to look at that rapid soil result from your irrigation water. And for those of you running manure, I think we're going to learn a lot when we start sending that manure sample in and seeing how bad the manure is tweaking some of those numbers. NutraDrip is your gateway to calibrated. Tim already touched on this a little bit, but basically we're the face to calibrated for you guys. So when you're ready to start going down this pathway, you'll work through us to get that information. They're basically training us on all these sampling methods and interpretation. So they'll be in the background supporting us both with products and advice. So looking forward to that journey this year. One of the questions, and this is a protocol that we'll send out as far as how we do sampling and where to pull things from. But one of the things to think about is when we do that rapid soil test, where do we pull the sample from? So for those of you that have worked with us and installed soil moisture probes, you know that if let's say we've got a drip line 40 inches apart, and if we put the moisture probe right between the drip line, we never see the moisture, right? So now if we want to pull a rapid soil test and understand what has happened in that soil, we need to pull that soil sample close to that emitter. So we're going to have to be specific about where that sample is pulled from, just like we're specific when we put a soil moisture probe in, because that water, we know that water doesn't move all the way across, and neither do the nutrients. They operate in a band. Especially during the growing season, that band can be pretty small because we're putting out a 1/4 inch of water, plant's taking a 1/4 inch up, and all of that happens in a real small band right around the drip line. So if we go pull that sample in between, we're not going to get accurate results. A few things on cost, just to give you an idea. A couple things we do have for you. So the SAP test, new and old sample combined, is $100 per sample. The rapid soil test is $51.50, and just a water sample is $70. So there's your sample cost. That does not include shipping and materials. NutraDrip in some areas will have the ability to do the sampling for you, depending on where you're located at. We're trying to figure out how to or we're trying to figure out if we're going to charge and how much to charge for the actual advisory portion of this. So one of the things that we have rolled out here that we've got on the table right now is basically a $750 subscription to join a learning group that will help you interpret those results. So that's what we're proposing, but that's still something that it's on the table. We're trying to feel out what that should look like. We do feel like there's value to that. We're paying Calibrated to train us, and so somehow we have to recoup those costs. I'm going to talk just a little bit more. Tim already touched on AeroWatch and Grow Guru, but I'm going to hit on those again just because of how important I think they are. Back in 2016, we were working with a fixed-wing aircraft company that was going around, and they would fly the airplane every 10 days. And they would take a thermal image of a field. And so this is our drip field just north of here, 3 miles. We've got a reservoir right here. You can see it's nice and cool. This is our drip field. You can see this zone right here is on. And we've got a center pivot right here. And you can see the end gun is on and where the pivot's at. And so I always like to go back to this picture because one of the things that it shows us, and one of the questions I like to ask is which direction is that pivot moving? Everybody says that center pivot's cool, the canopy, but I can't tell for sure. I'm pretty sure it's going to the right, but I don't know for sure. But the point is that plants, look at this drip field, plants cool themselves by transpiration. And so we understood by working with some of this fixed wing thermal imagery that we can use thermal to tell us what's dry and what's wet, right? We can use thermal to tell us that. Problem is we were getting this image every 7 to 10 days. 7 to 10 days doesn't really do us much good. And so when we found AeroWatch, and we started getting a daily thermal, there we go. We started getting a daily thermal image. It has helped us to, what I want you to think about when you think about this is irrigation variability. So this is a project, farm up in Nebraska we work with. There's about 700 acres there that we have highlighted. We got pivots and drip, but you can see the variability across this farm. If we were to look at this and say, well, where do we need to water today? You can see this pivot right here is pretty wet. This drip field looks good. Down here, this drip field is the driest of all of his acres. Now, just because it's red doesn't necessarily mean it's dry. It just means that it's drier than what's over here. And so that's one of the things that Pierre's been working with AeroWatch on, for those of you that have been using that, is that every day they change these values and they change the scale based on what is the wettest and what is the driest. And so, and it doesn't look like we're going to get them to adjust that this year. What we would like them to do is make it so that if it's blue, it's wet, and if it's red, it's dry. That's not the way it is today. The way it is today is blue is wetter and red is drier, but that doesn't necessarily mean it's dry or wet. So I hope does that make sense? For those of you that have been involved in AeroWatch, it's been a little bit confusing. We need to look at it as a variability tool, especially when we think about if I've got a probe, for example. Let's say I'm on this field here and I've got a probe up on the north end. The north end is drier than the south end. So now I can understand that, okay, the north part of that field, if I'm looking at the probe and it has this value, I can extrapolate that and now be pretty confident that if my probe is showing that I've got good moisture here, I've probably got plenty of moisture on the south side of that field. So we feel like this has a really good benefit for showing variability. It's not an absolute, hey, you're dry or you're wet, but it shows you variability across a large area. Permanent moisture probes, we're still definitely seeing the value in those and being able to see moisture and how it continues year over year. So basically, the old methods, we would have a probe in the ground for 2 or 3 months, and then it would be shut off and there wouldn't be any value until we got back the next season. Now with the Grow Guru probes, we're looking at from 2021 all the way to 2025, and we can see, here we are today. How does that compare to where we were the past winters? You can see in the fall of 2023, they were much, much drier. This probe was out by Salina, Kansas. I believe he had wheat planted here in the fall, so you can see it was really sucking the moisture out of that probe, and he was super dry in the wintertime. This year we're in pretty good shape. Again, the same thing on the full point. This back in 2022, he never did get his soil filled up all the way. It was always just a little bit below where it could have been. So being able to see that value over time is really, really powerful. These probes have a 7-year battery, so once we put them in the ground, they're going to be in there for 7 years, maybe even a little bit longer. This particular probe, I think, is the oldest one we have out there. It was put out in the fall of 2020, and I believe it's on track to at least hit 7 or 8 years. So we still like this business model. The price on these probes has come down significantly here over the past few months, so we feel like this is still a good value to help guys manage their irrigation. We already touched on redox. I'm going to jump to the automation side of things. So for those of you that have drip systems, and most of you have automation, but just reiterating the power of being able to see flow and pressure and know what to look at. So on a subsurface drip irrigation system, we have to monitor what our pressure is going in at the filters, and we need to monitor the pressure at the valve. That tells us if those valves have opened and closed properly. So if you're not familiar with this, make sure you get training. We're going to have some additional training just on controllers, probably in the month of March or April. Pulling that together, and then again, as we get to the irrigation season in June, we'll have some refresher courses on that. So really important to understand the controller side of it. I spend about 60% of my time right now working with manure. So this is kind of a passion for me a little bit, but it's something that we've been working on for 6 years now, I believe it is. This was actually the first lagoon we did on Todd's farm, just over west of Sabetha. Basically, Todd already had a drip system in. He came to us and he said, "Can I put manure through my drip system?" And he has a hog lagoon there on some finishing barns. And this is actually a picture of his lagoon. This is not what the first pump looked like. This is an improvement from where we started. But basically what we've got now on lagoons is we've got a floating river screen system. It has a 120 mesh screen on it. And so basically it just sits on the lagoon, pulls that water off the top, and leaves the solids in there. So that's kind of a really simple solution for guys that have lagoons that are less than 2% solids. If the lagoons get greater than 2% solids, it gets a little bit too thick, and we have to do some additional work to get that separated, and I'll show that next. So lagoons are pretty simple. We feel pretty confident in that. The next step was guys came to us that had deep pit hog barns and some dairies that had manure that was 7 to 12% solids, so a lot thicker material, and they wanted to be able to inject that through subsurface drip. We got teamed up with a company from Italy that was working with manure over there and have brought some of their equipment over now. So basically what we're doing here on the front of the trailer is we have a vertical screw press. That vertical screw press takes out the large particles. So it takes out all the hair, the corn hulls, the big solids, and you can see them piling up there on our demo trailer. And then it goes through what's called a microfilter. The microfilter has a 25 micron screen in it. And just to give you context what that looks like, a 25 micron screen is the size of a white blood cell. Okay, this is a human hair is somewhere between 50 and 180 micron. White blood cell is 25 micron. So that's the level that we're filtering the manure down to. For reference, a sand media filter on a drip system is 130 micron. So we're down all the way to 25 micron. The sand media filter would be closer up here to the human hair size. So if we have everything running right and we run through that microfilter, we will not flush our sand media filters at all. So once it comes through here, we send it to the sand media filters, and if those are working properly, this brown liquid won't even cause the sand media filters to flush. All the large particles have been taken out, and we can send that right to a drip system. So we're able to take deep pit hog barn manure, dairy manure, basically anything that we haven't found a manure yet we couldn't do this to. So this has been working pretty well. A couple key points I want to hit on with the nutrient loads, and this is especially important for guys that have high phosphorus levels that are getting regulated on how much phosphorus they can apply, which is a big problem for a lot of livestock producers. Once we go through the microfilter, so the blue line here is the source coming right out of the pit. The orange or brown line is after the screw press, and then the green line is after our microfilter. So you can see that the nitrogen and potassium are soluble. They're in the liquid. We're not taking those out. But after we go through the microfilter with the phosphorus, we're taking up to 90% of the phosphorus comes out as it goes through that microfilter. So now that phosphorus is in that dry form, and they can sell that, they can haul it somewhere. So it gives producers another option when their phosphorus levels are getting too high. On swine manure, it's not as large of a removal. It's about 30 to 50% that we get out with the microfilter, but it's still a nice amount of phosphorus that comes out. This is just a little video here of the machine running on a dairy. We have two of them side by side up in Minnesota. We get about 100 gallon a minute per microfilter, so it's a pretty simple process. It's been very, very successful. So one of the other things we're excited about, and we've been doing a little testing with, is we thought, well, now that we have, and this kind of goes to the question online, now that we have that manure separated, what else could we do with it? And so we took the manure and applied it to corn seed at 3 different rates, at 5, 10, and 15 gallons per acre. And then over here on the left, we did the same thing with 10-34-0, and then we had a control. And you can see that our emergence with 5, 10, and 15 gallon per acre of hog manure increased our emergence. We did a few in-field tests with this last year. We got good results, but the farmer that did the testing, he mixed it with a bunch of other things. In other words, he didn't do this test by itself, and so we don't know what he got his response from. He had a 17 bushel increase, but he stacked it with a bunch of other products, so we don't know which product gave the response. So our plan this year is to do this on 10 or 12 farms at least. So if you're interested and you have livestock manure, let us know. But when you think about it, livestock manure is valued at probably 5 cents a gallon, maybe 10 cents a gallon. So 10 cents a gallon at a 10 gallon per acre rate, we'd be looking at $1 an acre for starter fertilizer compared to $15 an acre for most starter fertilizer programs. So kind of excited to see what else we can do with that. We had that same producer also sprayed it as a foliar. He wide dropped it. The one thing I will say is running it through our process does not remove the smell. It still smells like manure, so you have to be excited about doing that. On drip irrigation systems, there are still some finance and government programs. The government programs are a little bit in question right now, where they're going to end up at, but there's an EQIP program to convert pivot or flood to drip. There's a REAP program that will convert anything that basically creates energy efficiency. So center pivot to drip will qualify, flood to drip will qualify. So if you have existing irrigation, you're looking to upgrade to a drip system, both those programs would be potentials to look at. DLL is still a financing option for us, so we can finance drip irrigation systems without taking a mortgage on the land. We've used this on a lot of projects, and it's been a really good program for us. So just kind of as a recap, what does NutraDrip all do? We're doing design, install, and maintenance of drip systems. We're now doing fertilizer products, moisture probes and imagery, irrigation as a service, meaning we have customers that are paying us to tell us when to turn their irrigation on and off, and actually remotely operating those, and then the manure separation piece. And probably the manure separation is the one that's growing the fastest. We have a lot of interest from the livestock industry on what we're doing there. But definitely the fertilizer thing we're excited about, the new testing methods. We feel like there's a big potential there for new growth. So that is everything I had for today. If anybody has questions, you can feel free to ask them now or be around.